The Department of Business. I'm going to take the topic about cloud computing. So, main the objective cloud computing use பண்ணி நம்ம என்னென்ன பண்ண போறோம் அப்படிங்கறத இங்க சொல்லிருக்காங்க. So, cloud computing definition. Let us see a cloud computing definition. So, are we using the cloud yet? So, from the picture, you can understand that we have lost the system which I have used. We are having many files over there, so which is going to use to store the data. So now the data, when we have a large storage, it is going to be a wastage of usage of space. So I don't need the cloud if I am going to use my external drive. So from the picture you can understand that. So these are the cloud service provider or cloud thing which are going to use. So Music Box and Dropbox, Google Play and Kindle and Online. So these are the service provider, and iCloud, YouTube is also going to use your cloud thing. So cloud service provider. So Kakai, Sony Computer Entertainment Company, which is going to use your cloud service. So Xbox Music, Evernote and Skype and Facebook. All these latest software is going to have your cloud computing. So NVIDIA, GameStream and Style Jukebox and SoundCloud. So these are the famous thing cloud which I have seen now. Then what is the cloud computing? Cloud computing is a new way of thinking and delivering an IT-enabled business service. So you can understand that. So I am going to use this IT technology for my business service. So you can understand that it is purely used for business-oriented services like application development and test. So from the definition you can understand that what is a cloud computing, where I am using my cloud computing. IT-enabled business services, where the business are used for your IT, information technology, both comes in the picture. Cloud is a new conception and delivery model inspired by the consumer internet service. And also the main thing is the end user is going to be focused. So cloud gives the features of self-service, sourcing option, sourcing this data. Here I am going to store. Economics of the scale. So here economics of scale is nothing but a cost oriented. Cloud is essentially an IT conception. So based on the conception of your data, I am going to give you an amount of bill for your usage. And delivery model that is optimized by the workload. So cloud is essentially an IT conception and delivery model that is optimized. Optimized means you are reducing it by giving your cloud. So I am reducing the burden by giving a cloud. So cloud picture shows this. The network is critical to the cloud computing. So the diagram, from the diagram, you can understand that clearly that I am going to use my network. So here network is nothing but your internet. So network of network. So I am going to have my connect with the mobile phone. You can use my mini note and tablet, and I am going to connect using my remote server, database, and netbook computer and personal computer. So every cloud, the network is critical to the cloud computing. So every cloud is some combination of a service and deployment model. So what is the deployment model? You can see it. So regardless of type of cloud, one fact remains true. If you don't have a network, means no cloud. So without internet or network, we don't have a cloud. So we can understand that net is nothing but, or internet is nothing but your cloud. So from the background, you can understand that. So I'm going to use my cloud as a source for storing my data. So without network, user cannot access their cloud service, application data, and user cannot move between the clouds. So without your network, I cannot access. So without your network, I cannot open my mail. So from this itself, you can understand that while using your network, I am going to have my cloud. So basic behind main aim is your cloud. So I am using your cloud service behind all the networks software what I am using. So infrastructure components that must work together to create a cloud cannot. So I am using your infrastructure. So these provide that must not that must work together to create a cloud canal. So infrastructure is going to be used as a services. So application, data, and user cannot move between the clouds. If I'm going to use the application using my cloud, I cannot share it. So main aim of a cloud is to share the data. Users cannot move between the clouds. So that is the thing. So attributes of cloud networking are attributes of cloud computing. So the attributes, what are the attributes? Scalable, cloud networking or cloud computing, self-healing resilience, low latency, guaranteed delivery, extensible management. So yes, extensible management from the name or from the topic itself you can understand what is scalability, low latency, guaranteed delivery, extensible management, and self-healing resilience. So let us see one by one. The cloud network must scale to overall level of throughput. That is, throughput is nothing but your input or data required to ensure that it does not become a bottleneck. So bottleneck is nothing but it doesn't mean that I'm coming to a situation that it is not possible. So that is a bottleneck. Low latency. The cloud network must deliver a micro second latency, that is your speed latency across the entire network fabric, because low latency improves the application performance and server utilization. So then, a guaranteed performance. The cloud network must provide a predictable performance to service many simultaneous application in the network, including your video, voice, and your web traffic. So you have to overcome these problems and you should give the assurance that it performs well. Extensible management, real-time upgrades and image patch management in large cloud network is a daunting challenge, daunting and important challenge to network administrator. So I can extend it wherever I need your data to be stored. So like your drive. So what I'm going to do using your drive, Google Drive. So I'm going to extend it wherever there is a need. If the user need it, so you're going to provide it. So self-healing resilience. So cloud network operate 24/7. So downtime is not an option. So it's not going to have a downtime. So it will work for all the time. From wherever you go, you can use it, your cloud. This requires a network architecture that offers a self-healing and ability for transferring in service software updates. So by using this, I'm going to sort out the problem, the cloud network. So what is the cloud computing? Part 2. So here you have computing power. Here this diagram shows your server. So the spanner symbol or service, that is your service management service tools are going to be shown there. The picture shows your man symbol or user and your application software or what are the application I'm going to use it. So network, the main thing is network, as I told before itself, network is the main thing. So data storage, the main purpose of your cloud is your data storage. So and also your cloud storage, the data storage, your another name you can tell it as cloud storage or data storage. So I'm going to use what are the service that is applicable. They are giving using your mobile and also your your tab, and you can use whatever the thing, you can extend it wherever I need it. So that is your cloud computing. Computing is a power. So visual model of a cloud computing definition. This is a cloud computing definition where I'm going to have my broad network access, rapid elasticity. Elasticity is nothing but I'm going to extend my data usage or data storage wherever I need it. So when using your drive, I can store it using your drive itself. I can have many sources. So you have a daily limit for using your the network. Measured service. So that is your measured. So I'm giving daily basis. I'm going to use your network. So daily basis means daily you have 1 GB or 2 GB for free. You can download the data and use my data storage or mobile data. On demand service, if I need it, I can have my demand, requirement. Demand means requirement, self service. So I can extend my connection even though I'm having the last process or last service finished. So the connection has been over, mobile data has been over, I can extend it wherever I need it. So these are the essential characteristics, and main thing is resource pooling. So data is going to be stored. So from the operating system you can understand what is this pooling or pooling. So resource pooling, data can be stored. So that is the main aim of your cloud computing. So software as a service, platform as a service, and infrastructure as a service. From this service model, that is, this is your deployment model, the service model they are telling, and they name it as the service model. Software as a service, you are giving a service. Using your software, I am going to give you a service. So, best example, what are the software I am using? Google, Drive, Gmail, where Amazon, where Flipkart. So, these are the software where I am using a software as a service. Platform as a service also you can give it. I can use it in your OS, whatever you have different platform. So I can use it in your Linux or Unix or whatever the operating system it may be. So from the diagram you can understand that I'm having a different platform. I can use it using your language also, application program also. So infrastructure as a service. I'm giving infrastructure as a service. So infrastructure, this building shows you have a different infrastructure, how many systems are there. So you're going to mention it, infrastructure, you're going to provide a facility for doing my service. So main thing, from the diagram you can understand that, so I'm having a deployment model as public, private and hybrid and community. So why they are mentioning here using your cloud symbol? From the name itself you can understand that. So I'm using your internet also basic behind your cloud services or cloud. Cloud computing essential characteristics on-demand service, broad network access, resource pooling. So from the point you can understand that computing resource. So I'm going to include your memory and bandwidth. I can extend my memory also and my bandwidth, that is speed also, can be pulled to serve multiple customers at the same time. This is the thing. So I'm having a multiple customer at the same time it can be served. The best example your Google Drive or Google Mail ID using your domain. So many person can access. The only thing is I'm going to give the restriction. So I'm going to give the access permission. Rapid elasticity. Then already I told that rapid elasticity. I can extend it. So ability to quickly scale in or out service with demand. So as the requirement is there, I can extend it at any time. Measured service. I'm going to control, optimize the services based on the metering. Here your metering is nothing but pay per use pricing model. So I'm going to pay according to my usage. So while using your mobile data, on the basis of usage, I'm going to have my mobile data capacity. So daily limit will be there. So you are going to have my bill or your measured service will be there again. Type of service include your storage, processing and bandwidth. Bandwidth is nothing but your speed. So measured service will be there. So daily limit will be, you will have daily your 2 GB or 1 GB gigabytes. Okay, so that is your measured service. So cloud service model, IaaS, that is infrastructure as a service. So I'm going to provide a provision server. I can extend many server, storage, that is your space or database, networking resources is going to provide a networking resources or networking data. Here you are going to have as a product or platform as my service. So I can mention you can use your TCS software. Nowadays they are using your TCS software for passport office services. So you can tell that as a platform. So platform as a service, middleware platform. So you're going to have both between your OS and my system. I'm going to have my middleware platform. So solution stack. So above problem we have a solution as a stack. So you all know you have a concept of data structure, stack where I'm going to store it. So both accessible over a network. So I can access using your network. So SaaS, from the diagram you can understand that here I'm going to use my software as a service. So I can use my mail, Gmail ID or your Excel sheet or your Google sheet or Google document or Google PowerPoint or Google slide. So software, fully your software as a service. So here your software as a service, you have your software and your application or services that are delivered over a network. So infrastructure as a service architecture. So it shows IP makes an entire computing infrastructure available. So here you are building, you are providing my infrastructure fully using your infrastructure as a service. So I'm going to provide my server and also your database. The main thing is network. So this is your D-Link modem or your external modem or internal modem, you can have it. So I'm going to show your network. So this diagram or this picture indicates your network. Here I'm going to use my hub or D-Link concepts. So manages a large pool of computing resources and uses virtualization to assign and dynamically resize the customer resource. So while runtime only you are going to resize. So as the customer require, demand or requirement. Customer rent processing capacity, memory, data storage, and networking resources that are provisioned over a network. So you are going to have the facilities. Infrastructure means you are going to have my data server and your database. So this symbol indicates your database. So either I am going to use my database server or whatever server I am going to use behind it. So developing an application, I can use both my database server and your network. So infrastructure as server means you should have a remembrance that I'm going to use my database and also my network. So here the platform as a service. From the name itself, you can understand that platform. I'm giving you a whole structure. So here the service provider plays a major role. Here service provider supplies the software platform or my middleware where the applications run. So you may have your ERP, enterprise resource planning or enterprise resource planning software. So for calculating my salary, I can use it. For separate software for calculating my salary. I can use even your tally. So you can use behind the thing is you are going to use my software as a platform. So service user is responsible for creation, updating and maintenance. Here the database queries plays a major role. I'm going to create the table or create the data source and I'm going to update it. If I need, I will maintain it. Sometimes the project may be a simple one or size may be small. So if you need the demand is there, I have to maintain it properly of the application. So the diagram shows your application and it shows your how to resolve your platform as a service. The sizing of the hardware that is required for the execution of software is made in an understandable manner. From the diagram you can understand that. So I am going to have only my application or software. Software as a service architecture. Service provider from the both the service that is your infrastructure as a service or platform as a service and also your software as a service. First thing you don't have a service provider for your first diagram. You can show, you can go back and see it. Here you don't have service provider. Here your infrastructure provider, that is your internet service provider, will be there. Here the platform and your software will have a service provider separately. It is responsible for the creation. What are the service provider? You have the Airtel, Aircel, and your Wi-Fi. That is your Vodafone, and your Reliance. So Jio. All these are your service provider for your mobile data or mobile network. The broadband services are your software as a service. Service provider is responsible for the creation, updating, and maintenance of the software and application. So here I am going to use my mail as a or Gmail as a that is software as a service. So from the bar chart diagram you can understand that I am going to use my Excel sheet and I am going to give my presentation using your bar chart as a diagram, and I will make understand the people what I am going to do for the future use. So here your mobile and your tab. So whatever the service can be used software as a service. Service user access the service through the internet based interface. From the thing you can understand that I'm going to use my either your mobile data or your mobile hotspot or your broadband connection. Nowadays, we are using only your Wi-Fi and your hotspot. That is the thing, internet-based interface. This is a cloud layer architecture, software as a service. So, resource managed at each layer. What are things running behind your software as a service? I'm going to maintain my business application, web services, multimedia. So, here the whole application is going to be your resource, your data. And example, Google Apps. Your Google Apps means you can use even your Google API, that is Google Maps, Facebook, and your YouTube and Salesforce.com. So the famous example is Salesforce.com. So I am using my software as a services. The platform as a service. Here my resource manager at each layer is going to have my software framework, Java. Here I am going to use my application, that is your platform, Java platform or Python or your .NET. I have mentioned that you can use even your OS as a platform. So you have different OS. So according to the need, according to the customer requirement or according to the customer demand, I am going to store the data. So software framework. So here I am going to use my platforms. So examples of your platform as a service is your Microsoft Azure, Google Application Engine, Amazon, that is SimpleDB. What is the software you are using your Amazon? Amazon Web Service is a famous web service you have. So you have a separate data server or repeated elasticity is there. Separate database is there, data server is there for your Amazon. It doesn't depend on your Google. So you can search using your Google alone. So infrastructure as a service, not Google alone, you can use even your other than your Google also. So infrastructure as a service, computation, virtual machine or virtual material, storage, block. So infrastructure is going to play a major role here. The thing is, I mentioned your end user side. I'm using my business application. So that is your computation. Computation means you are presenting it, and data manipulation is done. And also I'm going to store it. Data storage is done using your virtualization or virtual storage or virtual server. I'm going to store it. If even I lost my data here, if I'm going to use, I'm storing my data here, I can have multiple copies over there. So every area I'm going to have a separate data server in each service area. So Chennai is the hub. Chennai you have a service provider also and your infrastructure also. So I mentioned the data centers. So data center you have different data centers are there. You can see one by one. So Amazon EC2. Here you have to mention EC2, elasticity, component and elasticity again. Two words come and they are taken as a elasticity EC2. So two words comes they mentioned in a short form as EC2. So elasticity and elasticity. Go Green is also your infrastructure as a service and flexi scale. And also I'm going to use my data centers. So this is a cloud layer architecture. So cloud deployment models. Customers are choosing a variety of cloud models to meet their unique needs and priorities. So here your need is nothing but your demand, what I need. So this diagram shows your private cloud, hybrid cloud and public cloud and traditional IT. It's a normal model you are going to use your internet. community cloud. So on or off premises, either the service provider or you can use using on, that is in a company itself or outside the company. So premises is nothing but your company's mentioned. Cloud infrastructure operated solely means separately for an organization and managed by an organization or a third party. So example they given down there is an example for each and every cloud deployment models. Hybrid cloud, traditional IT is going to be used and I am using my cloud. So both the combination of your private and public are there. Public and the slash R. So both the features of public is also there and also the private cloud is also there. And remain separate but are bound together. Bound means joining or adding together by technology that enables the data and application portability. So wherever I need it, I am going to use it. Hybrid, you can understand. Hybrid mode, you can understand that. Even if I am in the place not here nearby, I can use using my hybrid. So hybrid is nothing but your network. So from one area to another, you may be in a different area or different place. Even though you are going to have a different place, I am going to use it. So portability means easy to carry. Wherever I am going to use it, I am going to use and do my services. That is my hybrid cloud. Available to the general public or large industry group and owned by an organization, you're going to sell the cloud services. So public and private have the difference. So it is going to be managed by the third party, that it is going to be organized by the organization or owned by an organization. Provision for the exclusive use by specific consumers with shared concerns. The main thing is community cloud. We have shared concerns. So security requirements, policy, and compliance consideration will be there. So for storing or for accessing my data, I'm going to give my permission. So community cloud will have a strong security requirements will be there. It may be owned or managed and operated by one or more of the organization in the community. So traditional IT, I'm going to use my appliances, pre-integrated system and standard hardware, software and networking. Business benefits of the cloud. So these are the business benefits. So cost reduction, scalability, agility and flexibility and reliability. So in what way I am going to have my cost reduction? If I use only, I am going to pay. That is a utility pricing. Economic of scales, that is your cost reduction. So pay as you go, that is the main aim of your cloud computing. So that scalability, on-demand provisioning. If I need, I can extend it. I can have a mini server or many storage or many drive or many data server as may needed. So elasticity. So elasticity is nothing but that extensible feature is going to be called as elasticity. So universal access, it can be accessed by throughout the world. That is a universal access. Self-service provisioning. So I can provide using my self-service. Multiple sites are there, reliability. Higher availability option is there. Disaster recovery offerings and security. The main aim of the cloud is to data recovery. Even though I may have a disaster or my crashes may be happen. So the main thing is I have to recover. So reliability feature means data centralization. The data is going to be centrally organized and going to audit and your compliance will be there. That is your result will be there, report will be there. Patching and maintenance. So I'm going to have my patching and maintenance. So if I need, I can extend it and do my maintenance. So these are the things. So importance of the cloud computing for development and testing. So high development cost to deliver the software, control and governance shares the software process, on-ramp and onboarding of team reduces time to software delivery. So these are the why we move towards my cloud. So Traditionally, while using these are the problems you are going to face, and if I am using a cloud, reduce installation and administration costs, lower TCO by improved utilization of software assets, better governance through standardized delivery of service, pre-configured software embodying best practices, tools can be provisioned in minutes, no download or installation are required. Installation or setup is required. So self-administrated portal to access to the software resources for globally. Globally means throughout the world. A distributed team is going to be done. So this is the importance of the cloud. Why we are moving towards my cloud? IT benefits from the cloud computing. So what are the IT benefits? That is information technology. So I'm going to have my increased speed and flexibility is there. I'm going to provide a text provisioning, change management, release management, service access, standardization will be there, separate software will be there for metering or billing, fixed cost and variable cost will be there. So both the options are done using cloud computing. So reducing cost. So I can reduce if I have a different copy or different services, I can use my cloud. That is the main feature. So service storage utilization, how many percentage are there? In a week based and minute based are there. Payback period, it can be years or month or daily basis also you can use it. So this is categories of cloud computing risk. Less control, technology immaturity, data security, vendor locking and security management, compliance, reliability are there. So less control means many companies and governments are uncomfortable with the idea of their information located on the system. They do not control. Proper control is not there. So that is the reason why we move towards the cloud. So technology immaturity, the person doesn't know what is the thing, when to begin, even though they have a knowledge of your data which to be stored. Lack of worldwide adopted standards, use of closed proprietary technologies, lack of knowledge and trust, API jungle. So application programming interface use பண்றதுக்கு தெரியும் ஆனா உள்ள இருக்கிற அந்த சாஃப்ட்வேர் பத்தி அவருக்கு ஐடியா இல்லாம இருக்கும். So data security, migrating workloads to a shared network. Migrating means move from one area to another area. I am totally what the service I am providing now totally goes to the next level. That is your cloud. Migrating means moving. Workloads to the shared network and computer infrastructure increase the potential for unauthorized exposure. So I cannot expose without authorized, that is your permission. Authentication and access technology become increasingly important. As you know that without your knowledge or without your permission, the other person cannot open your sheet or your Google thing which is shared by the owner. So vendor lock-in. So interoperability constraints are there, low level of portability, application and service based on the cloud. So complying with the SOX, HIPAA and other regulation may prohibit the use of the cloud. So for some application. So in order to have a different area, so maybe have a complexity will be there by using your SOX and HIPAA. So that's why they are not using the cloud in the area. So reliability, high availability will be a key concern. IT department will worry about the loss of the service should outages occur. Mission critically application may not run in a cloud without strong availability guarantees. Should guarantee that my data will not be lost. That is the main thing. So security management, providers must supply easy controls to the managed firewall. The main thing is firewall. As you know that I am giving permission to access only my data. I am going to give permission for only reading or editing as my wish. So that is the thing. Firewall means protection. Security and settings for the application and runtime environments in the cloud. So that is your dynamically you are going to run. So run the cloud or use the cloud. Cloud computing security risk. Security is among the top concern with the cloud computing. So people and Andy mitigate the risk. Mitigate means what does it mean to other? So associated with the user, give the permission, proper permission should be there. Application and process. So help to keep application secure, protected from the malicious or fraudulent use. The main thing is unauthorized listener, a person should not use my application. So data and information, understand and deploy it and properly have the maintenance and control the software and usage of sensitive data. Network server and endpoint, optimize the service availability by mitigating or moving the risk to the network components. Physical infrastructure, it provides the actionable intelligence and a desired state of physical infrastructure security and make the improvements. How can consumer think about a cloud journey? So you have to plan and build it and deliver it. So from the diagram or from the thing you can understand that your software engineering phases will come into the picture. Plan, build and deliver. So here build is nothing but your designing. So understand the strategic direction where my actual cloud goes and show the documentation and provide the proper data. Analyze the workloads. Workload is nothing but here it is concerned as application and your data. Determine delivery model. So which model I am going to use? Whether I am going to use my public or private or hybrid or community. So build a business case. Build it. Build means here your design and concept, quality assurance will be there, security and compliance will be there, life cycle management and deliver it. The proper delivery should be there. Deployments, your implementation are running the products, are running my cloud. Consume means usage. What I'm going to use. So manage. So managing or maintaining it and finally optimize it. So consolidate, create a roadmap for a cloud as a part of the existing IT optimization strategy. Consolidate, virtualize, and standardize, automate. So reduce the infrastructure complexity, reduce the staffing requirements, manage fewer things better, lower operational costs. This will consolidate, find out. So and give the solution. Remove physical resource boundaries, increase the hardware utilization, reduce the hardware cost, and simplify the deployments. So standardize and automate. So standardized service will be there. So you have a certain procedure, standard rules are there to be followed, and you automate it. So reduce the deployment cycle. You should not run it again and again. So or implement it again and again. So reduce the deployment cycle. So reusability will be there. So begin the process. Enable scalability and flexible delivery. So I can deliver whom the required person is there. So movement of traditional environment to the cloud can be in one step or an evolution. So I'm going to give a cloud-based provision for standardized workload, leverage the shared infrastructure based on the defined workload profiles, then automate it, then standardize it, virtualize and consolidate. These are the phases of your moving to the cloud. So cloud-based provision for standardized workload, leverage shared infrastructure based on the defined workload profiles, automate dynamic delivery, standardize operation via reference architecture, virtualize the server. So virtualization plays a major role. Virtualize server or application for increased utilization and automation. So consolidate, join it or put it in the same area where I am going to use commonly by the only person. So this is how to move towards my cloud computing environment. So server will be there. We have different networks. So disk will be there and different hard device or hardware device is there. We have a different tape or data. So Ansible and Ansible again they are telling Ansibles are the scalable pools of computing power and storage that are manageable as a single system. They will replace a multitude of individual IT systems and reduce the labor required for the physical system management. So I need not apply appoint a separate person for managing a cloud. So individually it can be maintained. So I'm reducing my manpower also, stack oriented. The cloud is an opportunity, we'll be able to take advantage. So I think you can understand from the given thing. Technology is enabling a smarter planet. You must face head-on the challenges to build an effective IT. Cloud computing is the one key way to address the challenges of a smarter planet. So conclusion, cloud fears largest stem from the perceived loss of control of sensitive data. Even though you may have a different crashes and natural disaster may be happen, I can recover it by having a different server in different area or different data centers. So main aim. So you have what is the main difference between cloud computing and traditional computing? So diagram you have already seen that. So cloud computing in educational institute, I'm going to use it, e-governance and your health sectors and agriculture. So usage models are there. So cloud-based storage, virtual hands-on laboratories, software as a service, platform as a service, infrastructure as a service. So these are 5 different cloud usage models that have been introduced to the educational institute. So cloud-based storage used to facilitate collaboration between the students by allowing them to work together on the same document. So the thing you can understand. So this is a cloud thing we are allowing. So this is your elasticity or your data server. Amazon what they are going to use it. So this is the another service provider and your Dropbox and your Salesforce.com. So virtual hands-on lab. So you can have your used to address many challenges faced by the educators struggling with the desire to provide the students with realistic learning environments, protect the production system from undesirable and potentially illegal interference. So in this usage model, the number of virtual machines are allocated to each student to test or execute a certain scenario. So ease up, you are making the process very easily and ease up the process of exchanging scenario, that is your sharing. Same concept are also applied in providing a testing environment in software companies. So these are the examples. So software as a service. So from the diagram you can understand that it's going to solve many compatibility issues. It's going to reduce IT complexity and cost. We provide anywhere, anytime access. So example, we have so SAS as an educational institute by Google Apps Education Edition. So these are the different software as a service. So Zoho is also the thing which provided where software as a service. Platform. So you have a different platform as I told, Microsoft, Azure and Google App Engine are the different platform. Service model will benefit the computer science students and instructor where there would be no need to spend time setting up the development environment. And you do not need a separate environment for developing this. It's already there. Only thing is I should know how to use it. So these are the example of your platform as a service. So virtual computing lab and your Edu Cloud, all these are their platform as a service. So virtualization is used to provide computational resources to user, though the user is one responsible for installing and configuring all the needed software. This usage model is closest to the grid concept. So you all know grid computing is there. So these are the example of your infrastructure, Amazon EC2, Purdue University, Terra, Grid, and Wi-Fi project. All these are example of my infrastructure as a service. So cloud computing in my e-governance. So how I am going to use my cloud computing in my e-governance? Using a cloud and service-oriented architecture, the public sector should improve the condition for development and deployment of e-government solutions. So cloud computing gives the permits to uniformly cover the whole country with e-government solution independently of divergence of the local administrative units. Best example, our government have separate sites for the state itself. That is the cloud computing environment. Service-oriented architecture facilitates provision of common services covering the whole customer process, where a customer may be a citizen or an enterprise. So G Cloud, that is your Google Cloud. The government application or government cloud or Google Cloud provides access to the G Cloud, which is going to have a service catalog which allows the user to view, compare, and request the commissioning of the service from the G Cloud. So health sector also going to use it. So using in different area, there are many services for healthcare. So it is a simple ability to record a medical history, and it will be in the hybrid mode where the other doctors can also view the history of the patient. So communicate this data to the healthcare providers. So cloud in the health sector is going to have a different thing to be considered. Cost, scalability, ubiquity. Cloud computing can make the same application available over a large geographical area without the need. Collaboration, storing a patient data in the centralized database for restricted access by authorized person. If permission is given to only view, you can only view the data. So collaboration. So these are the area where I am going to use my in my health centers. Agriculture, cloud computing in agriculture. Where I am going to use my cloud computing in my agriculture. So irrigation system, integration control, remote sensing, mobile fleet reporting system, agriculture information repository. Here your repository is nothing but your data server. So crop planning in the area where I am going to use my your cloud computing. Monitoring and irrigation automation system. So this is the thing service provided by the agriculture as a service. So the above thing is taken from the big data and adder principle and architecture, adder components, HDFS, adder development file storage, or distributed file storage, distribution, yarn and resource management. So this is a hard thing. Data velocity is going to be there. Real time, near real time, periodic batch. That is your megabyte, gigabyte, terabyte, and gigabyte are there. So the data will be stored. The data will be measured in the form of these things. So it will be in the form of table, database, photo, web, and audio. Data may be in the form of photo, web, or audio. So social, video, unstructured, mobile. So you may have a big data expanding on three fronts at an increasing rate. So these are the big data and AI landscape which is in 2018. So had on premises, Pivotal and AWS, that is added in the cloud, Microsoft Azure, AWS, Google Cloud, IBM infrastructure, and different services are there. So these are the big data and AI landscape in your 2018. So Apache Hadoop. So it's an open source software framework for distributed storage and distributed processing of very large data sets. You may have a large, huge volume of data may be there. I can manage it using my Hadoop. On computer cluster, built from the commodity hardware. All the modules in Hadoop are designed with the fundamental assumption that